I'm Steve, and welcome to our webinar on Geospatial and Minecraft.
All right, everyone, thanks so much for tuning in to today's really land-breaking, groundbreaking, whatever term we want to use, webinar on Geospatial and Minecraft, where we're going to explore the practical reasons and value of bringing geospatial data into a Minecraft world and what the implications of that are. So we've got a number of exciting things lined up to show you. We're especially pleased that we're being joined today by the original Minecraft FMEer, Ulf Monson, who really invented the whole idea, and he's going to tell us about that journey in just a few minutes. But I should also introduce myself. I'm Dale Lutz, one of the co-founders of Safe Software.
I'm Dmitry Bar. I'm a scenario creation and testing analyst here at Safe, and basically I get to play with all the cool stuff that our developers make.
And Dmitry, it turns out, is also quite a Minecraft guy. He's got 3 sons, so that's helpful in this journey. And he was the guy that, it was kind of a surprise, but you really were Steve. That was you under that box, wasn't it?
Really? Yes. No, it was Steve. He just left.
Right. Let's turn it over to Ulf, who's going to give us a good background. Stephanie, if you can make Ulf the presenter. And Ulf is just fresh from a trip to the Geodesign Conference in Palm Springs, where he presented a variation of this. And before that, at the FME User Conference, Ulf has talked on this topic as well. But Ulf joins us from Sweco in Malmö. And thanks so much for joining us today, Ulf, and take it away.
Oh, thank you very much. I hope you don't mind. I have this shameless plug for the FME World Tour on the screen there, and you see the URL where you can sign up to see all the FME stuff live. And we are engaged in arranging the ones in Gothenburg and Copenhagen in May, as you see there. So I kind of caught the opportunity here to do some commercial for that. So let's move on. And I'm really glad to be here. And I'm kind of flattered that you say I'm the pioneer in this area. I know I have a lot of colleagues working with it, and know other people who have been really committed to get data into Minecraft.
Yes.
So this is my first screen. Do you recognize that one, Dale?
A little too well. A little too well.
That was in my early teens. I really enjoyed playing computer games. It was something real magic. You know, you got a tape with this magic game. You put in you had a tape drive. If you were lucky, you had a tape drive.
I think I used to type them in, Ulf. I used to type them in.
Yeah, it was good until your mother vacuum cleaned and happened to turn the power off.
Yes.
That was it. Then you didn't have the story. But I remember that magic feeling. You put a tape in the tape recorder, and you waited for the computer to load, and then finally something wonderful appeared on the screen, some virtual world in there where you can interact, and it really got me into computers and so on. And at my first job, working with geospatial, I got this deja vu moment, because then the setup was like this. I got tapes. It was geospatial data on those tapes during that time, and we had other, that was Sun Spark Station, and I was responsible for getting that data into ArcInfo in that case. So, you put the tapes in the tape recorder, and you waited, and then some wonderful thing appeared on the screen. It was a real deja vu moment for me. Loading computer games, getting graphics, and interact with a virtual world, and it really got me into geospatial, and I could really see that there is something related in this business, gaming and geospatial. There is some kind of magic feeling in there, and I think that is something important, and that's something we can make use of. So I'll start here with this. This kind of looks boring maybe, but where I sit at our pretty big company group, we have IT people, but we do have a lot of city planners and architects, geologists, and so on, working with city planning and so on. And if I show this picture to those guys, they would probably nod their heads a bit familiar. So this is some way how you plan a city, or you need some kind of organization, plans, and ideas. Maybe not that most impressive picture, but if I told you that this is how my 11-year-old son explained to me how the planning of a city should be organized, then it's a bit more impressive. Now, So that's actually what happened. But my son didn't draw a chart like that. He and his friends explained that. I overheard the conversation when they were discussing building a city, and they did that using the game Minecraft. And for those who entered the poll there and said they really had no idea about what Minecraft is, so it's a game made by a Swedish company, Mojang, and there is estimated about 100 million players. I don't know the exact numbers there, but there's a huge amount of players playing this game. And the way to describe it in the short way, it's often compared to building with Lego, but in a virtual world. But it's a multiplayer environment. You connect and you create stuff. And there are different ways of playing it. You can play to survive, or you can play in something that is creative mode, which is the mode that is mostly used in projects where you do it, because you are free to build stuff in there. And it's kind of a block. It's a 1 meter resolution. You can say that where you place blocks. And I think it's the kind of the optimal scale to create something detailed enough to look appealing, but don't consume too much time to get things done. Now, so this is how my son and his friend started off doing this. I overheard them in his room. And you know, when kids nowadays play computer games, they don't only have one screen with the game. They're connected through Skype. They use cell phones. They text each other. They use Facebook. So it's really like a command centrals when they're connected in this game, and they really are collaborative when they do this. And what I heard them say was stuff like, "Oh, we're going to build a city. Yeah, we need a school. We need a fire station. We need roads." And then I heard them speaking about that they have to organize themselves, because this would take several days. So they had to have some organization. And what they really did in the game was they built a house first. And in that house, they really placed signs. As you can see, there says school planned, fire station built, and so on in there. So that's how they spontaneously organized themselves in building this city. And overhearing that conversation, it really sounded familiar. It sounded almost as my work, the discussion went in there. So that's what really caught my interest in trying to do something useful with this. Now, it's been known for quite a while that Minecraft can be used in city planning, and there are different projects that has been taken underway. But as far as I know, there has not been a standard, solid way to get geodata into Minecraft and also possibly get data out of there. So there has been quite a lot of projects that I guess most of data has been built in the game manually, or by some more like a hack where you import maybe a DEM or so. So knowing this and the experience from overhearing my son and his friend playing the game, we started dabbling with this, and especially me and my colleague Peter Sigerstedt here, we kind of created an early prototype to use FME, this tool, and get data into Minecraft. And this was a while ago, and these are some screenshots from the first prototypes, how it looked. The left one here is an IFC, or a BIM model. You can see the building with the blue roof is viewed through a CAD system, and the top picture with the red roof is when it's been imported into Minecraft. And to the right, some tests with getting OpenStreetMap data into Minecraft. And the idea there was to use OpenStreetMap data as a template for building houses and so on. Because that's one important thing with these projects, as my son pointed out, that if we do import stuff into Minecraft or the gaming environment, there should be still enough things to do in that world. It shouldn't be pre-made in every aspect. It has to be fun. So it got known that we had the ability to create these worlds. And in the summer of 2013, I was contacted by the Swedish Center of Architecture and Design, and they had this idea. I very well remember this phone call, and they asked me, well, we heard you have a way of getting data into Minecraft. Could you create a world with the entire Stockholm in it? So, of course, I said yes. But at that stage, remember, it was kind of a hack we had made, so it was a challenge. And the vision they had in this blockholm project, that was the Swedish Center for Architecture and Design, remember. The vision they had there that the Stockholmers would wake up one morning and all the buildings were gone, but all the other stuff in the city, the road network, the topography, hydrography, roads, etc., were still there. So maybe there had been a big hurricane or so, but if the Stockholmers wake up one morning, everything is gone, how would it look if it got rebuilt? And the idea was also to keep the actual properties in there. So we helped out with this project, and it was quite a challenge to get data in there. We had to create this 3D model in Minecraft by using the existing data. So we kind of converted 2D data, used height, a DEM, and stuff like that to get data into there. And there were thousands and thousands of players. We knew that it probably would attract a lot of players, so we also knew we had to have some organizations in there. And we set up a building permit system, which means that when you enter this virtual world, you are assigned a building permit. That is, you own a plot, and these are the real plots in Stockholm. So while moving to a place and building there, you can only build on your exact property. And we managed to do that by setting up a system where we used a geodatabase. We loaded that one with FME with the property data sets, as well as created the Minecraft world. So you couldn't build on other people's properties. And we think that was one important thing when you do these projects. And this blockholm project, I think it was really pioneering stuff, because the idea here was to really have an exhibit afterwards. And the exhibit was in March 2014. And what they did at this Swedish Center for Architecture and Design, they created scale models from what the people created in this big gaming environment. There were thousands of people building new buildings in there. And they created these scale models and had an exhibit where you could walk around and see how people really envision stuff like that. And I think it was a pretty big success. Thousands and thousands of people participate in this. So you can see me up to the left there standing by real Minecraft trees in this exhibit. And while I wander around in this exhibit, being a kind of a cool dad to have been involved in this, I thought to myself, what's been really achieved here? And of course, the architects at the Swedish Center for Architecture and Design, I know they got some really input how the city could be created, and so I think especially building tall buildings, because in Sweden we don't have this long tradition of building tall buildings, because it's we have a lot of space in Sweden. So that was one thing, that's all I know. But when I walked around there, I figured out that what's been done is really this. This is what you can do with a setup like that. You can crowdsource what can be or what could be in these scenarios when you create a Minecraft world and allow players to really build anything they desire in that environment. Now, quite recently, I know this is featured on the Safe blog too. I've been involved in a project here in the south of Sweden, which is called a project in Kristianstad, where the city had this plan to develop a certain area of the city. So I know they had heard of this blockholm project and wanted to do something similar. And they really wanted to reach out to young people and get their opinions and involve them in the process. And you should be a bit careful when you say only young people, because it's really Minecraft players that you're addressing. And I think that gamers and players of Minecraft and other games are getting older, because it's playing games is not only a thing for young kids anymore. So, but the audience here were Minecraft players, and we helped this city of Kristianstad create a setup for this, create a model in Minecraft. But in this case, they wanted the existing building. So we set up processes using 2D data, LiDAR data, and also some ortho photos in there to create this world. We did this with FME. So to get an idea how this look in the virtual world, you can see this picture here. So I'll flip back. This is aerial photography of the real world, and this is how it looked in the Minecraft world. Now, the more colorful buildings in here is what the players created in the world. If you look at especially to the right and up to the right, you can see that there are more real buildings. Those are the buildings that exist today, and these are created from mainly from the 2D footprints and combining the LiDAR scans in there. And you can also see the trees in here, and I would say that the vegetation is really placed in this virtual world as the places where it is today, where the vegetation is today, because that's taken from the classification of the LiDAR scans in there. So, and this is also the result. This is young players creating architecture in the city. And I'm not myself an architect, but I think it really looks quite amazing. It looks like modern architecture in here, even though you build with 1 meter blocks in there. And some other views from the city. You can see here that in the background you have the more original town, and in the front you can see some more imaginative buildings in here. Of course, you have to have skyscrapers today if you build something in there. And some other views. Now, the city had this idea to kick off this project. When we had created this model, we hosted a workshop where kids and Minecraft players were invited. There were quite a few. And it was a really interesting experience to see kids move around in this geography and create stuff in there. You can imagine that it would be a bit chaotic, but that really was not an experience in this case. And it was also quite a kind of heartwarming to see a 12, 13-year-old kid explain for someone at the municipality or the city planning office how to operate Minecraft and to build stuff in there. And the question in the title of this webinar, why you should care about this, I think this is one of the points to show people, say you are working at the municipality or an organization, that you really care about their opinions. That's one of the things that I think is important. Now, what's been cool in this project is, I mentioned when we did the blockholm project, it was kind of a hack we used. And now in FME, there is a standardized way of getting data, both into Minecraft, but also read data in there. So this is an example of how it looks. I think we will see more examples later on in this webinar, exactly how it works. But this is a standardized way of getting data in there. And what's even more cool is that as well as you can get data into Minecraft, you can also read data. And this is an example at when you set up a game world like this, a Minecraft world like this, there are hundreds, maybe thousands of players. If you publicly display that server that will work in this world, that means that there will be a lot of changes in it. And you can read data at different stages. If you save a copy of the world, so this is reading Minecraft data from August the 17th, and FME treats that as a point cloud. So if you are used to working, say, with the laser scans or LiDAR data, so I would say that by using FME, you can treat Minecraft data in the same way as a laser scan. And it's really the perfect point cloud because there are no nasty decimals in there. It's even numbers, 1 meter is numbers. So if you want to try different algorithms on point clouds, it's a perfect environment. And you can see here that it's been split out by different numbers, and you can see the 1, 2, 3, 6, 7, 9 there. These are really IDs of what kind of block type is placed in the Minecraft world. 1 could be, for instance, grass, and 6 could be some kind of wood on a building or something like that. So that's how FME treats that. And doing that, have that ability, as I said, means you can work with the Minecraft data exactly as you do with the other sources of point clouds, as laser scans. And there's a functionality in there, the point cloud merger, for instance. And that means you can compare, you can merge, but you can also compare different versions of point clouds. So here I read a Minecraft world at 2 different states. There's been a couple of weeks between these dates, and I compare them. And I can see what's have happened in that Minecraft world. So here we can see that stuff has been disappearing or removed, and we can clearly see that there are some building bodies that have been torn down, meaning that the players think that there should be other kinds of buildings in this area. But we can also see it seems like there's a lot of leaves that have disappeared. And it doesn't necessarily mean that people don't want vegetation in there. It merely means that as this is a living world, when you create a world, that means that the trees grows. So really meaning that the leaves have moved to another position. So here we can see what's been added, and we can see that we have these contours of new cool buildings. And what we have been experimenting with now is to do something more useful of this. Remember, it's point cloud, and they can be useful for illustration, but you can really make these into something solid, usable 3D data again. And maybe not that most impressive, but this is an example of how we process what's been added in this Minecraft world, create solids, and write them out to a Google Earth data set, for instance. So that means that you can have a setup where you crowdsource what people would like, and then you could also show that in your normal GIS systems, CAD systems, or say even BIM systems in there. So I have a little time chart here trying to explain what's happened here. In a couple of years ago, there was mostly manual building for creating this Minecraft world, maybe some hacks to get data into there, and then it has been shifting more to get real tools like FME to integrate data in here. And what I think will come and have been, there's a need for some more game logic, as I call it. With game logic, I mean the building permit system I mentioned to keep some order in there. But it can also be to say have a competition in the game, setting up what is the shortest route to get to my school or something like that, or maybe what's the safest way to get to the school. And I'm going to show this picture here there. So what's possible so far is we've seen quite a few examples of getting geodata into Minecraft worlds, and we say we create a workshop, and from this workshop we can create pictures, we can create movies and show stuff like that. But really what's been missing is to get these potentially massive amounts of crowdsourced data back into the geodata systems. So that, I think, is personally, I think is something very important with the ability to both read and write game data formats and Minecraft formats. But there are a lot of other games where this could be important. And as I say here, the fourth thing here, using game logic and create something logic in there. And I'll try to show a movie here, and we'll see what's been running here. And what we've been doing there is to set up a workflow like this. We have a Minecraft world, and we have set up connected that. So when you are in the game, you can query a web service. And this web service is hosted by FME server in this case. So what you do is that you, in the game, when you are a bit lost, you query for a special point of interest. In this case, it will be a fitness center that this movie will see. And this point of interest will get returned to the game, and the game will move you towards that correct place. And we'll illustrate that with the Danish GST Minecraft dataset. It's the Danish National Land Survey has released the entire country in Minecraft. So I'll try to show this movie here. I will not keep it too big, so it will move pretty fast. So this is me moving around in a Minecraft world. This world has been downloaded from the GST downloadable site where you can find datasets like this. So, well, moving around in here, I get kind of lost, and I want to find a fitness center because that's the first thing you think about, of course. So I enter a command in the game here, FME jump. I set FME fitness world, and this is the city of Aalborg, and in Denmark. So this will hit the web service and return the point of interest there and fly you towards that point. And the integration here could really be anything. Through this FME server that can create Minecraft objects, you could really stream any kind of objects in here. Really, you can feed live traffic and so on. It seems there's a lot of horses lining up to the fitness center, getting busy to do workouts in there. But you can still you can see that there are some bats in training there. They managed to get the membership in time, obviously. And you could do other stuff with game logic in the game. So here's an experiment too. I will do this towards the end here. And what will happen here is that I'm placed on a wolf and shot away through the air towards the location I'm going. So this, the bad thing with flying on wolf is that they fly pretty well, but they don't land very well. That's one of the problems with that. But this kind of, as a technical preview, you can really create game logic depending on geographic data and do something in that game. So let's see if I can get my presentation back here to end up with that. And talking about why you should care. So as I say, show that the city planning office, the municipalities do care, but also get people interested, because I know discussing with city planners and so on, it's quite easy to get people interested if it's something that's being planned in the city that acutely affects your own property. Then you can get some interest. But in the big picture, what will happen with the city in the long run, this is a way to get out to kids and get their opinions and mostly get them interested in this. And also, my personal point of view is this, is also to show kids and get them interested in any kind of geospatial data. I started this presentation with showing that I started my career by playing computer games, which led me into this geospatial career and care about geodata in that case. So I think those are kind of things that are important in this setup. Now, I'm going to finish with this picture here. What you can see when you set up these projects, as you can see, people tend to behave in the virtual world very similar to how they behave in the real world. So these are the kind of low resolution picture here is a live example of really what happens. Someone is kind of disturbed what their neighbor is building in their world. So they set up signs, please keep your property tidy and so on. But this thing that you behave in the virtual world as you do in the real world, that is something many gaming companies know. So making use of gaming and geospatial, another way of thinking of this is to do as they do. Because when they do testing of new games and so on, they put out beta tests or alpha tests, and they can really see how people move around in their virtual worlds. They have the ability to tweak that environment to say you want people run down 2 streets, you want 500 people to run in a game towards the East Street, and you want 500 people to run along West Street. But it turns out when they test this that everybody's running down West Street in this virtual world. What they can do then, they can analyze that and they can tweak the environment and see that they really move in the direction that's important for the gameplay. And that's also something that I think will affect the geo-design process. Imagine simulating road networks, planning road networks, and stuff like that in there. So I'm approaching the end here, and on my presentation, and I'm very glad to have the possibility to show my picture of my ostrich. This is the geospatial ostrich, and explaining what FME is to me. And have you seen this one before, Dale?
No, that's a new one. I'm sure our marketing department will love this.
Yeah, I took this picture 2 summers ago, and I've been struggling to work it in. Now I managed it, I think. Do you think I got away with it?
Yes, that's great.
So FME is much a tool to get to any kind of data and interact with it there.
Well, great. Thank you all for your flexibility. It's been interesting to see the journey, and actually, like you, I began my career also by playing games on old. I was an Atari guy, and then I remember being excited. I had made a moonscape, and you know, that was my first spatial thing. Was kind of hand coding a moonscape into an Atari, and so as the old commercial used to say, we've come a long way, baby, since then. Yeah.
I think to get that wow feeling now, you have to think about graphics like in the City Engine environment where you emulate something really cool in 3D.
Yes.
But then we were not very spoiled at that time.
Yes. So what we're going to do now is, Stephanie, if you can flip over to Dimitri. Alf's done a great job of laying out the motivation and some of the use cases and the projects that have been done so far. And now we'll switch gears to show you how, at least actually, what we've got about 4 or 5 scenarios that we've worked with people on.
Well, I will show 5 different scenarios how these Minecraft worlds can be made and what things we should consider while making them. So
Dimitri's going to show kind of a practical how-to, and we'll look at a few different ways of combining ingredients to make Minecraft worlds. And at the end, actually, we're going to give you a tutorial, basically. There's an online document that describes all these, so if you don't fully understand what Dimitri's up to, you'll be able to look at this later as well. So let's take it away, Dimitri. I'll let you run with it.
Yeah, so this year's FME theme is Easter Island. So we decided to make one of the worlds, well, just take the Easter Island data and make it into a Minecraft world. So we had just a simple raster file and OBJ 3D models. You can see them here.
The statues.
And yes, and we also had some locations of those points. Well, we just went to the Easter Island and took a few GPS coordinates around the island.
And we put them in SharePoint this year.
Yes, but the example here will show it in CSV for to make it easy.
Yeah.
So and this how the output could look like, and I'll show you what it takes to get to this. So this is the workspace.
Yeah, zoom her up.
Yeah, so here we bring the TIFF, the DEM, to the workspace, and here we read our statues. Then these statues.
Zoom her up a little bit more.
Yeah.
There we go. Okay.
The statues initiate reading the CSV file with the coordinates. These things still don't touch Minecraft yet. Then we drape the points to the surface of the DEM of our elevation model. So, and then what is important, that any geometry that comes into FME can be turned into a point cloud. So basically here we say make our DEM, our raster, to a point cloud. Here, down the road, we say the same thing for our statues, which are now spread all over the island. Make them into point clouds. So, and then, so what is, yeah, as we already said, that Minecraft format is just a point cloud for us. So then we have to set two things. We have to say, specify block ID and block data. What are those values? Wrong window. We should go here. Yeah, so here you can see all those blocks. They have these numbers. These are block IDs, and the smaller numbers beside them, small indices, they are block data values.
So this is really the palette you have to work with in
Yes,
Minecraft.
yeah, you should basically have this table all the time when you design something in Minecraft.
Yeah.
So, and this is what I specify here: block ID and block data, and this way I set tall grass. The same is as here I'm setting podzol or dirt or just simple grass. So because any vegetation needs something to grow on. It cannot be just any stone. It can be something like grass or dirt.
So sometimes you have to place, if you want to put something down there, you put something underneath. So
yes.
You must subtract one off of Z.
Yes, that's what I'm doing here. Here I offset all the vegetation a little bit higher.
You add
offset along Z, one block.
And then put the dirt underneath.
Yes. So, and then the statues, I just say make them out of moss stone.
Okay.
And now we probably, so, and after that we just combine all those point clouds in a single point cloud and save to Minecraft.
Right.
This is it. So the Minecraft part is pretty simple here. So it's setting block IDs, combining, and saving.
Dimitri?
Yeah.
I would say that the point cloud combiner, it's you can pretty much throw anything on that one and turn that into a point cloud.
Yes, yes. Well, I did that here. So here I combined it into a point cloud. I had to do that separately to set the components.
Yeah.
Yeah, but it can take any 3D object, and that's how we do the BIM models and other things to Minecraft. So you're going to take a quick look around Easter Island.
So here is the Easter Island with the statues.
Yeah.
I can try to fly. And if I go in any direction.
The other thing for folks at home, we used some logic in FME to find the closest point to the shoreline and rotated the statue so they're looking to the ocean.
Yes.
So that was another trick in there. But that gives you the rough idea of the process. You take the ingredients of your spatial data, you rearrange them, turn them into point clouds, decorate them with the right block IDs, and out to Minecraft, and off we go. And that'll be the pattern for most of these that Dimitri will do. So yeah, let's go from there.
Yeah, let's go to our second. So here we already saw that we had to set the block ID and block data. And speaking about world size, well, we probably will have to scale our data. So in XY, we probably often don't want to make things to scale 1-to-1. Because it may take as much time to go through the world as it would take in reality. And in that, we are limited by Minecraft. It can go up to 256. So even the highest mountains, we would have to scale down to fit that.
So that
range.
is for geospatial people who are used to having the whole universe to work within. Minecraft, you do have to consider a scaling always.
Yeah.
And that's part of the artistry of creating a Minecraft world. So what's the next example, Dimitri?
So that's we take a simple LAS file downloaded from Norway Kartverket, Norwegian Mapping Authority web service, and this is how it looks once it's visualized in.
Let's go ahead and take a look at that service. They have a prototype going using FME, and you basically, I think Bola is on the line. He's the guy that worked with us on this?
Yes.
And so you basically can pick an area and then download that, and that is actually FME technology running underneath that as well.
And I think I picked this area.
Yes.
Yeah.
Okay, so
we can see it here.
there we go.
Yeah, and then we take it to Minecraft. Here is the workspace.
So this is taking
so,
any kind of LiDAR that was classified.
So we just read last file and split it by classes and keep on the ground and high vegetation.
Okay.
So then we generate our DEM so that our last file, which is irregularly spaced point cloud, will become a regularly spaced raster,
Yes.
which then can be turned into a regularly spaced point cloud.
Yes, because that's the key that's really the key thing. If you're starting with a point cloud and you want to go to Minecraft, you got to make it regularly spaced somehow.
Yes.
Yeah.
So then we extract with our FME magic the polygons, the polygon for the island with this hull replacer to have the shoreline, and then the polygons for the vegetation areas here in these three transformers. But then the Minecraft itself again is pretty simple. We again use point cloud combiners to turn the raster into a point cloud and vector polygons of the vegetation to point cloud, and then we just plant some trees, flowers, make beaches, and set water. So this is it.
Yeah. All
and
right.
save it to the point cloud. So to the Minecraft. And the output can look like this.
Right.
So we can see that. And in this example, I show how naturally grow vegetation. So I don't place trees, I place saplings, and they grow over time. So on this image, this is, I think, one Minecraft day old image. But at the beginning, I had no trees, just saplings. But you can see that in a day, you get a nice forest here.
Yeah.
And where we see lots of flowers, these are flat areas with no high vegetation.
Go ahead, Al.
So if you did that example I showed in my presentation where you compared the different data sets, you would have seen how the trees and leaves had grown.
Yes, exactly.
Yes.
If we compare afterwards, that will happen.
And now here you see this color under the ground, which is actually, I made everything what is under the surface, I made it out of glass. So you can go underground and see the transparent hill inside. That can be very useful if you make tunnels, if you, something like a perfect picture, perfectly oriented tunnel or pipe or something. And then you can, with FME, go back to this world, read it, and replace glass with stone. So then it gets more realistic.
Yes.
So that's another trick that you can do with FME.
Okay.
So now we can go to our next example.
Right.
I mentioned that we should replace irregular point clouds with regular ones.
Yeah.
We naturally grow vegetation here. So now an example where we take traditional GIS data, shapefiles and mapinfo files and DEM to make a Bowen Island world. It's a nice, beautiful island really close to Vancouver. And here is the workspace. Maybe I should show the source data. Yeah. Here is how it looks if you would visualize it in Data Inspector.
Yeah.
So mapinfo tab, these polygons with attributes representing different kinds of forest, roads, and streams.
And of course the DEM with the
and
elevations.
DEM, yes. Yeah. So that's why the background is black, because it's the lowest point.
Yeah.
So and here is the workspace. Here I buffer all the linear features so that they take some width within the Minecraft world. Otherwise, they can just disappear, be overlapped by other points. I clip them so that we have non-overlapping polygons representing streams, roads, and the rest is vegetation. And then we set styles. Here I made a simple custom transformer where instead of typing block ID and block data, you can just choose from whatever is available.
Okay.
Yeah, lots and lots of things. It's maybe easier in some cases, but we probably need a proper transformer where you would see the pictures.
Yeah.
You should put a dragon egg in there.
Dragon
egg.
Dragon egg. Wow, that seems like a dangerous thing to plant.
Well, at this point, we cannot place items.
Well,
we can make only bricks.
I see a stone monster egg there, right above your mouse.
Yeah.
That seems frightening as well. But a trapdoor would be good to have next door to the monster egg.
Yeah. So and then we send everything to this Minecraft rasterizer. Here, it's maybe interesting to show how we can do. So here, then we rasterize everything, all the vector layers and raster. We bring to a single raster model. Here we rasterize not by elevation, but rather by block ID and block data. So we force our vector features to the elevation of their block data or block ID.
Yes.
Then combine everything into a single raster, rasterize and combine to a single raster, which has several bands. The first band, this band number 0, is elevation, and the rest, the second band is block ID, the third is block data, the fourth is offset for the vegetation.
Yes.
So it's not required by the writers to have that offset, but we can add as many bands as we need to manipulate our data once it's brought to the point cloud. So, and when we brought this this raster to point cloud combiner, each band of the raster becomes a point cloud component.
And then you can use that to set the properties in Minecraft.
Yes, and then I can fine-tune it by adding some conditions. So if component, former block, former band, former attribute is that, do that. So you can see some of the conditions that I have here. So, and eventually I write everything to Minecraft.
Right. So let's take a look at what that the result.
So here is Bowen Island in Minecraft, and here you can see how it looks like in Google Earth for comparison.
Yeah.
So, and the fairies come here, so then you can go for a walk, like in real life.
Yeah. So that's good. That's an example of really some more cartography inside, and combining the traditional GIS to make a very realistic output. All right, next one.
So
I think we covered all these.
Yes, we covered all these. So now beam data.
Yes.
So we can take IFC model or Revit file and SketchUp file and bring them very easily to Minecraft. That's probably the simplest workspace. Here we simply read an IFC file. Here you can see roof, ramps, windows, stairs, walls, everything. Then we simply style them with this transformer, scale. Well, the model, the original model, I think was in inches, so we need to change it to something, so different units, and combine into a point cloud. So the bigger part here, this one is the simplest one. It's just we make some ground around the building.
Right.
But the building itself, we offset it to the elevation, to some elevation, 70 blocks high, and well, basically save it to the Minecraft world.
So let's look at a couple of the screenshots of what these look like. But really the trick is just assigning the block IDs based on the original classification. So that's the original IFC model in an IFC viewer, and here it is in Minecraft. And then we have another one that we were given from a customer in Minnesota somewhere that had done one using a Tekla. This is actually, he gave us the concrete beams basically of a building, and then this is what we created. And so we were able to, Dimitri, you put the glass on the front somehow.
Yes, yes. The original model didn't have glass on the sides, so that's what I added. But we can fly there, and you can see some holes around. On the right, we have a model. We have an option to populate terrain. Basically, that will place some lakes of lava or water, add some vegetation, replace some of the blocks with sand. I don't know why here, but it will give this model a little bit an post-apocalyptic look. That's how you can go inside. But you can see the stairs look really well.
So you didn't make those stairs?
No.
That's in the model.
Yeah, they were in the model, and they, well, turn out pretty nicely.
So nice open office floor plan in there.
So and you see, yeah, that hole is due to the writer option. Of course, we can turn it off and have a really nice and
yeah, a little
building.
less.
Yeah, and here I placed 25, I think no, 50 buildings And because they don't have any spatial, real coordinate system, we had to keep that in mind and spread them around a little bit with Minecraft transformers, with offsetters and things like that. So that's our fourth scenario.
I can comment on one thing there, Dimitri.
Pardon?
Yes. Yeah, go ahead.
Once again, you mentioned the stairs in there, that it really got created in there, and that once again, I guess, is due to the magic of the point cloud combiner.
Yes.
That you have a 3D object of the stair, you run it through the point cloud combiner, which will really turn that stair into a point cloud.
Yes. Yeah. And it just worked. So yeah, we did the walkthrough. So I think we've already covered these. The scaling is the interesting thing, and I know Ulf, some of the customers are asking, or the attendees asking about scaling, but that really is, especially with these BIM models and so on, a key thing, and I think you've had to deal with that too.
Sure, sure.
Workspace, I can show you. I had to scale the model, and I scaled it a little bit differently along Z, so that it fits nicely, so that each floor is not that high. But we saw that it looks pretty normal.
And I know one last thing on scaling, and we won't get into the Ulf's real tricks, but I know, Ulf, you've done things where you've almost created like a TARDIS from Doctor Who, where the outside is smaller than the inside. So
yeah, you can do stuff like that.
There's
if
tricks
you
like
are,
that.
yeah, because there is a limit on the scale how tall a world can be. You can really have multiple universes that you jump back and forth.
Yes. Okay. So we'll just touch briefly on this. I'll talk through this one. Our friends at Esri sent us a nice example where they were using City Engine rules to. City Engine is a tool that Esri has that takes 2D data and other attributes and then rules written in this language called CGA and creates 3D worlds to be used elsewhere. And so they created a 3D world of a city and then dumped that out, and then we brought it into Minecraft afterwards. And so it's a nice smooth workflow, and this is one that we look to work more closely with Esri. And again, here we're generating the 3D world and then allowing it to be explored in a gaming environment, starting with really just raw 2D ingredients, and then through the magic of the City Engine in doing that. So that's a pretty impressive one. So thanks, Brooks and David, for letting us show this today. So again, the CGA rules create the 3D world, and then they are classified, or they know the kind of material that they need to be rendered in, and then all we do is a lookup from the material that City Engine wanted to appropriate block IDs, and off we go.
So, and the workspace looks very similar to this one.
Yeah.
We read them, we map them to Minecraft blocks, and saved as a Minecraft point cloud.
Yeah. Okay, I think this is our last one, isn't it, Dimitri?
Yes,
we have about 5 minutes left. We'll just spend, I know we got folks from a railway company online. They'll find this interesting, but you can start to do some more advanced tricks to use some of the blocks types in Minecraft that actually have some intelligence around them, and that's what Dimitri has done here. So we have a linear network. In this case, we did the Vancouver SkyTrains.
Yes, and when you place a rail block in Minecraft, it looks around and sees how it should be oriented. When you place all the rail blocks at once with Minecraft Writer, they don't know how to be oriented. And this orientation is a block data number. So we have to analyze how these blocks should be oriented before saving them to the Minecraft.
I think we won't. We'll just look at the thing. We won't. I think we shouldn't bother looking at the workspace in this case.
Yeah,
I think
okay.
it's too. But we'll look at the technique and we'll give folks the workspace afterwards. So this is the output, and you can see how behind our rider there, you can see that the thing curved a little bit and it's connected nicely. And so the trick is, if we look at here, we densify the lines by adding more points. We scale that and round it off to truncate it to integers, basically. And now we have a blocky line, that's the green line. And then what Dimitri does is replace that whole thing with squares, and that allows us to do adjacency testing. So you can see who's got a shared border.
Yes, I use Spatial Relator, it's our wonderful transformer, and I see where the adjacent blocks have a line as an intersection. So it will take only blocks that are to the north, to the south, to the east, and to the west, and not the corner ones.
Yeah.
And we can analyze these neighbors and basically pick from the available list of orientations the right one. Just write condition that would specify the correct block data.
Yeah.
And once we save it to Minecraft, we see the properly oriented rail blocks.
Yeah. So we'll maybe look at that afterwards. We can go for a ride on the SkyTrain.
Yeah.
Okay, so that's a bit more advanced one. Then just some other scenarios that Dmitry has worked through. We've done eruption of Mount Rainier, so we created Mount Rainier and then somehow put lava on the top.
Well, it's very easy. You have buckets of lava. You just go to the top and spill it there, and go a little bit to the sides, and look how lava flows down and burns the tree. So you can. That's why I said that disaster planning is quite interesting, or investigating it to show kids or anyone what would happen if an eruption happens, or a forest fire. Here we have Stanley Park, and they set it on fire. But what is interesting, once it totally burned off, the vegetation started to regrow. In the middle, you can see the fire is already set, and you can see the new trees growing right after the forest fire. And here we see the map of Europe, and by accident, not on this image, but by accident, I raised the sea level by 1 block, and that was about maybe 200 meters of real life, and basically I saw,
so we got bad news for our Dutch and British friends, basically.
Yes, basically for the Northern Europe.
I think Sweden, I think all of you are in trouble as well.
Oh no.
Yeah.
But we will build Minecraft walls in there. We got.
Then I tried to not only to erupt the Mount Rainier, I also built a huge roller coaster going from the top of the mountain down, and it's really very fun to ride down on a minecart along the rail blocks down the hill. I made a maze generator. I made the whole city of Toronto. I took almost 400,000 buildings.
400,000.
400,000, and it took 25 hours to generate the world. Took some time, but now with a certain mod in Minecraft, I can take a car ride across the streets of Toronto.
Yes, and you made the buildings out of wool, so it's not dangerous if you hit them.
Yes.
So that City of Toronto has made a 3D model of their city available, as a part of open data, and that was what we did there. So I think, do we have what's the next slide here? Yeah, we have a gift for everybody. We only have 1 minute left, but if you want, go to fme.ly/maze generator, and we'll give you your own unique Minecraft maze.
Yeah, 2 mazes actually, identical mazes, where if you can play in multiplayer mode, you can run and see who is the first to pass this maze. Yes,
and so that's an example of using FME Server to create Minecraft worlds kind of on the fly, and so that's something that we expect that some folks may want to do as well. And the article that we promised, and maybe Stephanie, you can chat that out to everybody, is the detailed article is at that fme.ly line, and Stephanie will chat that out, and as well you'll get in a follow-up. But this will tell you in more detail how to do all the things we did today. So it's all there for you to look at in very great detail. So just to wrap up then, we got a webinar coming up about data quality, so you can tune in the future to other ones. Oh, and I actually should hop back. Our broadcast room in Minecraft is showing there on the Safe Software office on the 2nd floor, so that's handy to know. And we got our world tour. Alf already mentioned it. We're going to 60 cities worldwide. Come out and see us. It's a free day. And again, we'll send you out that link. And Alf is hosting 2 of them in Sweden. We've got about 17 of them in North America we're doing, and then partners of ours worldwide. And so I think that's there's the location of it all. Whoops.
That's the end. Yeah.
Yeah. So I think if we just go like this.
Yeah. Okay.
So that's it, folks. It's 9 o'clock. We appreciate you sticking it out till the end. We're going to do a couple things here. If you need to leave, go ahead. Otherwise, we'll sit and chat a little bit with Ulf and some of our questions and answers, or we'll try to get some questions going. And then if anybody's interested after all that, I'll do a basic intro to FME, like a little tiny demo where I make some 3D stuff if someone wants to stay for for that. So thanks so much, everyone, for tuning in. We'll hang around for Q&A if anybody wants to do that. But let me also, before we part ways with everybody else, thank you so much for your pioneering work and for being willing to speak about this today, and really for this effort that I think is very important in terms of opening up our thinking as geospatial professionals as to how we can engage a much, much broader audience, which can only help as our world grapples with issues with geodesign. You know, if we educate our population, our young population who will someday be decision makers and have to clean up the mess we're leaving them, this is only going to help them all to make better decisions. So thanks so much, all.
Yeah, thank you. I'm flattered. I'll forward the thank you to my son and his friends too.
Yes, yes. So let's look at some questions and answers. You know, I did have someone ask me both on Twitter and now during the thing about doing stuff underground. And what do you have to say about the underworld? You know, actually using Minecraft for mining. Have you had that Alf at all about anybody looking to go under, like, subterranean?
I know it's really not a big difference working on top of it. I mean it's still a point cloud, so you have to make certain that the point cloud you create is aligning with, say, you have a geology or something like that. But it's not really a big difference with working with stuff on top of it.
Yes. So if you did have location of 3D pipes and stuff like your storm sewer, I know we've got Amanda from California, CAD, on the thing. I know she's had data in the past like that shows the works of the city. You should be able to put that in there, and then you could go underneath and kind of take a look around.
Yeah, it's not really much different working. Say you are used to working with geospatial data and create maps. Then you have to think of a way, to arrange the layers in there. Yeah, maybe you have the land usage in the bottom layer, and you have stuff on top of that. You have to think kind of the same way when you create a Minecraft world. As Dimitri showed, you have the different symbology, which is the codes for the different blocks. Could have been colors or other symbols. And when doing this stuff where you are, say, creating geology, it's much about the order you put stuff into the Minecraft writer. You have to make certain that nothing is writing over each other and stuff like that.
Yes. So someone else has asked, Stephanie wants us to share webcams. Okay, we'll do that, Stephanie. Someone else asked, how did you create that building permit system? Do you want to talk a little bit about that? Because that's an interesting, we didn't really cover that. That's outside of this, but it's really a key thing that you did with the server itself, the Minecraft server.
Yeah, I should give some credit to a colleague of mine, it's Björn Hattel, who made a short Java snippet on the actual Minecraft server at that point. So when you place the block in the Minecraft world, there's an event fired, which by this little Java snippet queries a PostGIS database.
Right.
If this coordinate is within the geometry borders of your property. So most of the intelligence was in the PostGIS database that we loaded. At the same time we created the Minecraft world, we loaded the PostGIS database with the correspondent property borders, you can say. So when you place a block in the Minecraft world, the PostGIS database was queried. So.
Yeah. So that was the key, interesting thing to connect a server mod. And actually, it was my son that put up those signs because he was mad at his neighbor there having a mess. But the server mod prevented my son from going and cleaning up that guy's mess, which would be what he would normally do.
Yeah.
Yes.
But it's an interesting thing with those rules, because when you set up a project like that for the public, you kind of have to think about the balance of the rules. Yes. I mean, you shouldn't totally kill creativity. That means you have to allow certain things. So there's some kind of fine-tuning you have to do there, setting up the rules.
So, it's interesting because I think the Danish one, there was some famous thing, and I don't know how it happened, but the Danish one got hacked a little bit, and somebody had put a nice American flag over in Copenhagen or something like that. So what did they do, or how did that even happen, Ulf?
That particular one, I don't really know. I mean, putting a flag in there doesn't sound that terrible to me. But yes. I think there was some other occasion where someone figured out to to send TNT or dynamite on a minecart. So, I mean, there are so many ways to do things, create things in Minecraft world. So even if you turn off some certain bricks or objects, there are ways to create new objects. So
yes,
probably someone figured out a way around there.
I know that one of our customers was talking about doing two things: having a downloadable version of a Minecraft world that anybody can take and do whatever they wanted to, and then another one that would be a server that would be locked down, which would be read-only, so you could wander around with other people. So that these are interesting methods to deal with the freedom that's possible as well as allowing creativity.
I mean, you showed this example of the Norwegian cart bucket and this download site where you can download LiDAR data.
Yes.
You could very well just add a writer in that workspace that's running on FME server to create the Minecraft world, which means that, okay, I want a Minecraft world of this area instead and play with it. So that could work right away.
Yeah, yeah. So let's see, what other things, somebody asked, can we take multi-patch data that comes from a shapefile and put it into a Minecraft world? Dimitri, do you want to answer that one?
Yes, definitely, very easily. It's no different from the IFC or SketchUp models that we used. So the first example probably is the best match for this one. So when we read just OBJ files.
Yeah.
So we just say, make it into a point cloud, and the FME makes a point cloud. And then we just set the block ID and write it to Minecraft.
Someone, actually it's David from Esri that works with us in City Engine, asked if we can create holes in the point cloud underground like air blocks to simulate karst. I don't know what that is.
Well,
do you know that?
Yes, of course. My education requires knowing what it is.
I don't know, so it must mean I'm not a cartographer. KARST topography. So is that a simulation that's possible?
Yes, although we really need random number generator
right
in our point cloud expression evaluator.
Right, so that's one of the things we don't have is we didn't design a random number thing inside of our point cloud work.
But I always needed it for raster expression evaluator and for point cloud expression evaluator.
So you want random numbers in there to do the stuff like this. Yes. So someone has created an underground soil type. Brian, I wonder what that means. Do you know what that would mean, Dimitri?
Well, we can have a look.
I'll just take a look.
Maybe I should do that. Okay.
Let's see. Let's take a look. Soil types underground. Mine is coming up very slowly. Yeah, why don't you try to take a look? Are we sharing your screen? Oh, there it is. I see. So just a bunch of layering. The person has sent a thing where you just layer different soil types to make your underground world. So I think who's our panelists on today? Any other questions we should answer?
Well, we probably should tell the story of that head because we promised that in our yesterday's.
So just bring the box. Yeah, this is funny.
So I should tell the story. So my wife, who is also a safer, Elena, went to the post office to buy a box, but she really didn't know what size she should buy, and she was hesitant in front of the post office worker. And the worker asked, what are you looking for? What do you need? And my wife said, well, I need a box, but I'm not sure about the size. What is it for? The lady asked. Well, you know, you see, to put a head inside. And probably she looked pretty, well, strange. But the post worker just said, you know what? Don't worry. I understand. It's Halloween. Coming. Just before you, here was a lady, and she needed to buy lots and lots of wrapping paper. And for what? To wrap up a body.
So I guess the post office will get interesting
requests.
Yeah. So Lena got away with it anyway.
Yeah.
So that's that one. So I think with that, we'll probably. Somebody says it like the after party that we have here. So I don't know, Alf, if you want to see, I'm going to try my hand. If Stephanie can make me the, if somebody's interested, I'm going to do a tiny little bare bones basic demo. So Stephanie, can you make me the presenter? Okay, whoops. I'm showing my screen. Okay, so probably the webcam is on, and yeah, okay. So this is a tiny little example. If you've never seen FME starting from base principles, I'm just going to go and make a 3D world out of some two things. I've got a DWG file and a CSV. So the way we would typically do this in FME is we have a part of it called the data inspector that helps us understand what the data is that we're working with. And so I'm going to just take this DWG file, drag it on there, and I'm going to say OK. And now, a couple of things. This DWG file, an Esri person had worked with it, so there is a coordinate system with it, which means I do have a background map. And my friends from Vancouver will recognize this as being in the Granville Island area. As well, this has extended entity data in it, so I've got some kind of an ID and a base height on it. Okay, that's good. And now, the other thing that I've been given was a CSV file. And let me go see if I can find that CSV file. Here we go. And I look in the parameters, make sure it looks good. I got a couple things in there. All right. So then with the CSV file, I can take a look and see its data in this table. And I've got, again, that outline ID and a mean height. So I've got a base height that's from the AutoCAD file, and I've got a mean height that's in the CSV. And the difference between those two is the actual height of my building. So with that in mind, I'm going to go then to FME Workbench, and I'm going to create a workspace, going to join those two things together. So the way I would do it, I'd say, okay, make me a blank workspace. Here I go, and I drag out the DWG file. And there we go. And I've got my outlines, my building footprint outlines. And then the next thing I'm going to do is drag out that CSV file. And again, I'll just double check that the settings are all good. Yep, looks good. And so now I've got my CSV file. So I'm reading these two things in. And what I want to do is merge them. And so to do that, I use something called a feature merger, which is going to basically join two streams of data. And I connect this up, and I can join these two streams by the outline ID. Both of them had a key field called outline ID. I'm going to join on that, and that's all I need to do. And now what I can do at that is run this with this little icon called Run with Full Inspection that'll read all the data and kind of do that join and kind of show me what I've got. And I can double click on any of these. 332 features were read from each one, and there was 332 merged features. And so if I double click on that, that should bring back my friendly data inspector. And there it is. And now I've got a much richer attribute set here with all these things. But the most important thing is I've got my two fields, which are my two heights in there. So that's what I'm quite excited about, is I should have in here, yes, I got a base height, and I've got an, let me see, what was the other one? Mean height. Yeah, I got those two things. So with that in mind, I now can take this data, and I could just click on that and say I want an extruder that's going to take that 2D building footprint with those two heights, and I'm going to extrude by an arithmetic expression. So I'm going to drag out my, let's say I want the mean height minus the base height, and just like that, if I run this again with full inspection, I will now have, at this port here, I should have some 3D objects. If I bring those up, let's see. Come on, Mr. Data Inspector. There it is. Okay, and there it is in 3D. So I got my 3D heights, and so if I, or sorry, my buildings, and if I just tip them up, let's see, you should be able to see that there's some relief there. And so I've got something that looks good. And so now the last thing is, let's just go ahead and make an output. And I'll add a writer. In this case, I'm going to go to KML. It's always a fun crowd favorite. And so if I just pick a place to put that, let's put it in the output folder, and I'll call it b2.kml. I did this last night. And I'm going to say, let's make a manual output feature type called buildings. Spelt wrong, that's fine. And if I take and drag that to there, now I've got something going to KML. And for good measure, I can also do something like this and go to PDF. So let's choose to go to PDF. 3D PDF is always fun. and I'll do b2.pdf. Whoops, I missed PDF here. Good. b2.pdf, and we'll do that. And again, I'll say buildings, and so I'm outputting my 3D to those two things. I go ahead and run this. This time I'm not going to run with inspection. I'm actually going to just let it do its thing. So there they go, writing all those features after extrusion. And there we go. We're writing our KML file. And as well, we'll be writing our 3D PDF. And then what I'm going to do is just hop on back to the Mac to look at the results. So let's see, there goes the PDF. Good, we're all done. And if I pop back here and I look for my Finder, and here they are. So I've just done B2, so let's just see if I can get my 3D PDF, which is going to be a little bit dark, but folks at home should be able to see that I've got buildings there without context. Okay, so that's one thing. And the other thing was the K2. So I'll fire up Google Earth, and you should see that coming. And we'll slowly navigate to Vancouver area. And there we can see those fine buildings that we just output. And so that's just a tiny intro to FME. If you've never seen it before, you basically work with data. You can rearrange things. The key is knowing what these transformers are that can merge and manipulate your data, and you can create things like this. So that's my tiny little intro. Ulf, have you ever used the extruder?
Oh, many times. It's been very useful.
You guys have created 3D models of nuclear power plants using techniques like what I just showed here today.
Yeah. It's the same principle, but some more logic in there to keeping track on what floor you are.
Yeah.
And also some intelligence to say you have elevator shafts and so on that are going to several floors. You can do this, the analysis needed to handle that into the FME workflow too.
Yes. Hey, you should be able to take your nuclear power plant and put it in Minecraft.
We should do that. Yeah.
Have you guys?
I can say so people don't get too worried. It's a power plant in the process of being dismantled.
Right.
So it's,
you could crowdsource the dismantling.
Yeah, that's.
Each
that's
person can carry home
topic.
one block.
Yeah.
Okay, so I think that we could probably sit here and talk FME and Minecraft all day, but I think that we probably will sign off here then. Any other questions that are worth raising to the group? Dimitri, did you see any?
Well, but everything will be available as a download from
Yes.
the webinar page, and all those examples that we showed today are available as downloads in the article.
Yes. So that's right. Folks will be able to go and recreate all this stuff with FME 2015 and the downloads. Everything is there. And actually, I did see that somebody actually is working with archaeologists on Easter Island, and was quite intrigued. So we should come clean and say that they're totally fictional locations that we put for the statues. But it would be great to have a real data set of that.
So Dimitri didn't go to Easter Island?
No, neither Dimitri nor Stephanie. It's all phony. It's a big fake. But actually, some guys are on Easter Island. Maybe they could provide us. I think as well, Dimitri, didn't we exaggerate the scale of those statues?
Yes, they're much bigger than in reality.
They're larger than life.
The island is smaller, and the statues are much bigger.
Actually, it was kind of funny. We did notice the background maps. We in FME we can have variety of different background maps, Bing, Google, and so on. They actually are quite different for Easter Island. Some of them, we won't say who, are missing a lake. But I don't know how big the lake actually is. It could be a little puddle. I don't really know. But we did notice that the landing strip for the airport is about the width of the island.
Yeah.
It's pretty darn small. So anyway, that was fun. I think, Ulf, any other closing comments from you?
Well, I mean, if you think about creating a Minecraft world, I mean, the biggest part of getting the world working there is kind of if you are used to creating map data, 3D data, and so on, I mean, it's similar processes you do in all other kinds of these projects. So I mean, it's as you showed here, generating 3D by extrusion, maybe reading data from an IFC file like that, and then with the magic of the point cloud combiner, create a point cloud that you write out.
Yes. Yeah, and so really, you know, in some respects, while it is quite magical to see this stuff in Minecraft at the end, the techniques for getting there are actually tried and true and have been around for almost 10 years.
Yeah, yeah.
So it's really, really fun. So I think with that, there's still almost 200 of you still watching. Thanks so much for staying till the bitter end. From beautiful Surrey, British Columbia, it's a nice day. We can even see mountains. We should make a Minecraft model of those mountains, Dimitri.
I should.
Yes.
I should make the Minecraft model of my town, the city of Port Moody.
Yes, would be interesting.
It's nice.
So anyway, we'll say goodbye to you all. Thanks so much for tuning in, and good luck making your data accessible and available to a broad demographic of people as you explore and consider the techniques we showed today. So this is Dale saying goodbye.
Thank you very much, everyone. Here is Dmitry. Feel free to talk to us. Thank you again.
And Ulf?
Yeah, bye from Sweden.
All right. Enjoy the rest of your evening, Ulf, and we will enjoy our day here. Goodbye, everybody, and thanks so much again for tuning in.